Hello everyone, thanks for coming. My name is Brian West. I'm the General Operations Director at FreeSWITCH Solutions, which is the commercial entity behind FreeSWITCH. I'm also one of the co-founders with Anthony Minessale and Michael Jarris. If you guys have any questions about our commercial offerings or anything that we can do for you commercially, please see me at the booth in the expo, and I'll be available to do the questions after Anthony is done talking. I'd like to give a moment for Anthony Minessale, please.
Hi, and thanks for coming. So first I'll go over who our team is that's here this year. As you just met Brian, we also have Michael Jarris and myself. We've all been contributors to Asterisk in the past, though about the last 10 years we haven't been doing quite as much as we did in the first 5, but our names are still in there somewhere if you look for them. So when we get to the important question of what is FreeSWITCH? It's a fork of Asterisk, right? That's a question we get a lot. And no, it isn't. It's not at all. FreeSWITCH is a software application open source project that we started in 2005, and it was actually written completely from scratch. So to answer the question exactly what is FreeSWITCH, it's a software that's designed to run on a cross-platform environment, and it's meant to do interoperability between several different formats, protocols, encryption levels, etc. So one of our original goals is to be able to translate things in between various formats that are out there on the internet. It's also a platform that's used for multimedia applications. You can do things like write voicemail server or a conference server or IVR system. So it has lots of different facets. It can be either used as a central hub to aggregate carrier traffic, from 100 ITSPs up to a upstream provider or CLEC. At the same time, it could be used as something simple as a little conference server with a couple people having a call once in a while. So it scales from a Raspberry Pi up to a 48-core Xeon server. It's also an open source project that has a worldwide community. We have people from very, very many countries. We never actually tried to figure out all of them, but we know from experience of all the different feedback we've gotten from contributors that it's pretty far reach. And then we often get this question, but not so much in the recent years, because this has been like a 12-year effort now, but still you might wonder why you bother with this, because there's already Asterisks. And these are some of the reasons. We're very focused on the idea of doing a cross-platform application, and dealing with, at the time, it was a crazy new idea of higher frequency audio, stuff like not just 8 kilohertz, like what was the standard when we started the project, but the idea of 16 kilohertz was starting to become on the horizon, and by now we're up to 48, but we wanted to be able to pre-plumb for that kind of thing. That was one of our main goals. And we really like doing Asterisk development. It's a fond place in our heart for it, but frankly we were just a little too crazy for Digium at the time. They're trying to stabilize Asterisks, and we're always out there at the sledgehammer like, I have a new idea, let's like rip all this code out and change everything. And it's just kind of unfair. And it's kind of harder to deal with, so we felt like we should go play on our own sandbox so that we wouldn't, become such a burden. Because we were, at the time, developers, committing code and stuff, and we were too tempted to do like too crazy things, so we decided like we'd just do it in our own project. That way, if we break stuff, it'll be our fault. And the idea was that we were trying to build the application known as a soft switch. At the time, there was completely owned by the proprietary market. Soft switch differs from a PBX in the fact that it's meant for carrier traffic and for having each individual leg connected to the server have different routes and stuff, rather than being more centric to a PBX, which is to connect a lot of phone devices. We were worried more about connecting SIP trunks from various providers around the world. So a lot of multi-tier aggregation of traffic. That was one of the big things that we were really popular for in the early days. And that's, so this is what we were like in 2006 when we were new. We're primarily focusing on this ITSP and trunk aggregation, and then back then the ITF was interested in inventing chat, and the Jabber guys were trying to invent a voice protocol. So it's like two opposing forces, like the North and South Pole's axis from the old Dr. Seuss thing, you know. We don't need you, we can make our own voice protocol. And they're like, we don't need you, we can make our own chat protocol. So back then, Google was working on something called Jingle. This is something that was basically the idea of taking XMPP chat and adding a voice element to it, with the idea of a peer-to-peer kind of, you know, while you're chatting with someone on Instant Messenger, you could call them and talk. And so this inspiration started that long ago. And so Google invested in this Jingle stuff, and they implemented a Google Talk application that was for Windows originally, that basically was the first version of a sort of buddy list that included calling people, you know, with a headset. And back then, we tried to implement the spec, but we realized that Google only helped write the spec but not implement it. Everything they did was pretty much like slightly different from what it says. So after some fun with playing around with their app and packet inspection and whatnot, we invented Moddingling, which was our Jingle compatible, Google Talk compatible thing. So you could use this Google Talk client on Windows to call into FreeSWITCH and then bridge out to SIP, or join a conference and, you know, get all the stuff that FreeSWITCH can do. So then in the next several years, Google took what they did have and they added Google Voice, which I don't know if anyone remembers Google Voice, but it's pretty popular. You know, basically they use the same process to get phone calls out to the PSTN. They also had inbound calls, you know, with little extra stuff you could do. So what happened then was they ended up putting it in their HTML5 mail client with some kind of a plugin that would allow you to make these same kind of calls from your Google Gmail login. You know, they started putting a buddy list down the side. They still do it today. The first version of that was some proprietary plugin they had to write, and they didn't like that. But all the while, we would follow them and try and stay compatible. Then, around the same time, video was starting to be more of a thing. Like, it was kind of a parlor trick back then. There wasn't very many things that supported video. SIP phones would only do, you know, 320 by 240 and 640 by 480 max video, and so we added video support, but what we mainly did with it was pass it through. You know, someone wanted to do a bridged video call. It was really kind of far out of the mainstream, but it started to kick in more, you know, close to 2013. Polycom was getting into making video phones. And then, a lot of that time, there was our Moddingling could actually allow interoperability to Google Voice. A lot of people are doing really cool stuff, like they'd find a hardware enclosure device that was meant to, it's like when you put a hard drive on a network and then it becomes like a shared storage device. But it was actually running Linux, so they would hack the firmware on it. And then they'd put Linux running on there with FreeSWITCH and then a Google Voice, you know, they call Google Voice with our module. And then they like basically make their own free SIP trunk. You know, like they'd have a bunch of phones on the desk that would go into this little hard drive and it would send the calls out to Google Voice and they could get free calls. But this was around the time when WebRTC started to emerged. Now, this whole time, the Google talk and the jingle stuff was all kind of based on some code that was known as GIPs back in the 2005 era. They had been using it, and they used it to build their Google Talk application, and they decided that they could rip out the core part of that and use it to try and make like a new media stack. So that's when they purchased it and made it into what we know now as the WebRTC.org code. And at this time, we were really focusing on SIP, trying to get the most out of getting like all the funny little, like most of the SIP phones used to ignore, proper presence and voicemail subscription stuff, and they're all starting to get a lot more close to the rules and following them more properly. So we did a lot of work on implementing that. And so we had a little bit of progress with that. And then in 2013, we decided it seems like the right timing, I guess we need to implement WebRTC. And we had sort of a disadvantage because being a legacy application, it wasn't so easy just to go grab the new free WebRTC.org code and shove it into FreeSWITCH and say, oh look, we can do WebRTC now. We had to do stuff that was compatible with all of the things we already had, because we wanted to be able to use the same media stack to do things. And at the time, we were excited by it because it seemed like, if you didn't read it very carefully, it was like, what? Oh, they're going to add audio and media, audio, video stuff right into the browser. I'm going to be able to take my handset, my U-Link phone or whatever, and I'm going to, call my web browser with it, and it's all the same stuff. It's going to be great. All I have to do is just make a new module to, carry the stuff over. But what really turned out to be was it almost exact stuff that the jingle was using, as far as using combinations of ICE and setting up calls with candidates and stuff. And it did use an SDP, but by no means anything close to what anybody would have known as an SDP back then. We had little tiny SDPs in those days, and these were pages long, screenfuls, even on a bigger terminal. And really there is no real compatibility between any SDP coming out of a browser and any hard phone or any other kind of service or anything. So we realized we had to do a lot of work to implement a translation layer with that. This is what we started to do. Our SIP module back then used to contain a lot of code for media handling because it was really the only one that used an SDP-based system. We took it out and put it into the core, centralizing it so that other modules and things that used SDP-based media would be able to leverage it. Then we implemented all the various RCs that were necessary to make WebRTC possible. They're listed there. And we had to figure out how to test it because there was no existing thing to call, so it was a little bit of a challenge. WebRTC chose not to have signaling to leave that experience up to the implementer. So what we did was we had to try and get media flowing somewhere so we could even see. Most of our development is done, tried and true by endlessly attempting to do something until it starts to work and hammer away at it. So there was already a bunch of ways to make a WebRTC browser call another browser to just exchange SDPs with each other, and it was point to point. So that was a real quick demo. Look, WebRTC can do phone calls. But when it came to actually terminating the FreeSWITCH, it was a little more challenging. So we actually saw that someone implemented an entire SIP stack in JavaScript. Now that's not the weirdest thing I've ever seen implemented in JavaScript, but I was pretty much laughing at that one for about a week. Because I just trying to imagine, I've seen x86 emulator written in JavaScript that can boot the Linux kernel. So, but compared to that, I mean, okay, fine, give me a JavaScript instead. So, but Camellia was actually capable of doing WebSocket SIP pretty quickly after it was adopted. So, since starting from square one, we had no support for anything. We just took Camellia and translated it from WebSocket SIP to UDP SIP. So we could just make a call from the SIP stack in the browser and point it at our existing media stack. And now we have, you know, a way to push like a live WebRTC media stream setup into our software. So after trying it for the very first time, we found complete and utter incompatibility. There's just, can't even list all the hundreds of things that weren't there yet that we need to be able to do in order to make this work. So pretty much we had a lot of trial and error coding where we, you know, reading up on all the specs and figuring out which set of protocols that we had to implement in order to get, you know, there's a bunch of RFCs and whatnot for WebRTC. So we realized we had most of these things, but just never actually kicked them all in at the same time. We still had all the experience from the Jingle days, so a lot of it was overlapped because once the media stream was up, it was pretty similar. It was not as secure on Jingle as it is now on WebRTC though. So in order to do that, we had SRTP for a really long time actually, but this was usually negotiated through SDS, which is where you put the key in the SDP. And WebRTC uses DTLS for that. So we had to get that to work in order to set the key up, because that's where the key exchange works. And FreeSWITCH being a server-side application, a lot of the work with WebRTC stuff is focused around browsers being the only input. So there's a lot of times where there's a little, you know, not foresight in making a server kind of role in WebRTC, which they have now. They call it isolate. At the time, they didn't have that, so we just worked around it however we could. And we realized we'd like to not use JavaScript SIP if we could help it. So that was just a way to get things working. So we did have some challenges because for once we got the video in there, that's nice, but all we can really do is pass it through to somewhere else. And WebRTC is trying to reduce the amount of different I/O ports open, you know, for NAT, transversal and stuff. So they try and pretty much dump all the traffic. You have one socket that's a combination of all the different media stuff, so you have to do a lot of demuxing to get like which packets are audio, which are video, which are ICE, you know, etc. So we had to do a bunch of stuff to implement all that. And what we did have working originally was a video conferencing that was in a pass-through mode, so we could do such a thing like monitor the voice, so whoever had the video, the floor of the conversation, which we would measure through an algorithm we used, whoever we felt was the current most dominant speaker, we'd switch the video stream to match theirs. Although the browser receiving end is very, very finicky, and we would trigger all kinds of bugs in it by when we switched that video stream around. The timestamps and whatnot would all be different, so they'd freak out and they'd jitter buffer would choke, and it would take like 30, 40, 50, even 3 minutes, you know, to start showing it again, because it thought, oh look, your timestamps are all like completely different. Like you must be broken now or something, it would just freeze up, so all that kind of stuff. So the first thing we did was create the Virtual protocol, which is our own WebSocket signaling protocol, which is native to FreeSWITCH. So that rather than using a fully functioning SIP stack written in JavaScript, we simplified it down to our own protocol that was more intended to work with HTML5 apps to do other things besides just call setup. We wanted to be able to, you know, get live controls and get events about what's happening and such as calling a conference and being able to see who's talking and stuff like that all over the same protocol. So we built that. We added support for stereo audio in FreeSWITCH, which is something I always wanted to do, but there's really no device in existence that even tries to do stereo. So once that was a possibility, we implemented it, and it was pretty cool. Right now, actually, I think Chrome broke it again. It was working like almost immediately after we got this going, but like a month ago, I had a file log with them because somewhere along the way the stereo stopped working. It still works on Firefox, so I'm assuming they're going to fix it. But when it's working right, it's actually sending stereo audio. So if you're playing like hold music that's a stereo file and you're wearing headphones, you can hear it on both sides. Or you can do spatial positioning stuff with our conference module where you can do kind of pick a space where you can put them. So if you're talking on a phone in a conference call to someone and there's 5 people, you can kind of hear their voices coming from a circle around you. Or when you call a video conference, we kind of position it based on where you might see their squares. You know, if we're doing a multi-screen view of people, like if it's 2 people side by side, you'll hear one on the left, one on the right, and that kind of stuff. So once we got that basic video working, we realized that we needed to do more and be able to do transcoding with video. So what we ended up doing was adding transcoding support into FreeSWITCH so that we could do things like bridge call between H.264 and VP8, or have a conference call that contained users with both those codecs at the same time. And we converted our conference that we already had with the pass-through to more of an MCU, which is a form of conferencing that stitches together all the inbound video of the participants and lays them out in various shapes. So we can do like we define a layout pattern in our config, and then it'll adhere to those. It can automatically grow to shrink the people down so more can fit as more people call. Or you can make some presentation ones that have a fancy background. If you're trying to have like you can have them overlap and make it look sort of like Google Hangouts. So all these different MCU features allow us to kind of take all the input video streams and do what we want with them and send one stream back out to everybody else. And just basically once we could do that, we tried to add video where it seemed important. We put the music on hold supports video, so if you put MP4 files in your directory, it'll dump out video music on hold streams. So kind of stuff like that. As we came along, this would be cool if this also had video support. We've been just sort of tapping it in there as it gets interesting to anyone. So what's going on now is that the WebRTC JavaScript API is hitting the 1.0 standard. They're probably already working on the next one now to break everything that I do. But for now, there's a standard. And we started using Adaptive.js because it really kind of matured into the best way of coding to the standard, because it implements the standard completely faithfully as a shim, and then will translate it to any idiosyncrasies that might happen between browsers, because that always happens since day one. And the first time I ever did any web development, I've been plagued with every browser has their own way of doing stuff. So it's no different in WebRTC. So we started using that and made it a little easier to deal with all those changes. So that allows us to get our WebRTC to work on more places. So on a good day, it's working on Edge, Safari, Firefox, and Chrome. But we gotta try it every day because it's still evolving even now. And an update shows up and all of a sudden everything's different. So we're always on our toes about that. But yeah, we have pretty much starting out with just a basic media SIP engine that could do ULA audio calls and stuff, and ended up with fully functional WebRTC that can do multiple different audio rates and video combinations. And that's pretty much it. And if anyone has any questions, just let me know.
Does anybody have any questions?
Who here has used FreeSWITCH?
Almost. I have a question, not so much FreeSWITCH, it's not so much a FreeSWITCH question, but just a WebRTC question. What sort of, this is a really kind of a transformative technology in a lot of ways, I think. It's kind of exciting for people. What sort of stuff turns you guys on? Like, where do you guys get excited and think, oh, that's going to be really cool or really hot in the future? Or do you feel like you're even there yet? Does that make sense as a question?
I think the video was preoccupied the last couple of years because it just wasn't useful before. I was over in the E-Link demo booth over there in the expo hall, and now they can do full 1080p video calls from this desk phone, which was not normal before. So being able to take advantage of that for stuff has been really the most exciting thing lately, because otherwise, like I was saying earlier, video was kind of just like a parlor trick. Like, yeah, we checked that box, we can do video, but it was a little tiny screen, and like,
Yeah.
now we got 1080p. Thanks to 4K, 1080p is just ubiquitous, like cheesy level now, so that's good enough for most people. Like having 1080p all on your phone and on your mobile and all these other cool places that it wasn't before. That's really opening some ability to add like a visual element to stuff. You're more likely to actually do video calls. We use our own conference module for our workplace because we're all distributed. So we call into there and somebody gets a phone call, you can look at him and go, oh, that's why he's not answering. He's got a phone up to his ear or whatever, and he's muted, so I'll just wait. Or if you're annoying somebody, you can tell. You're looking at their face when you hear what you're saying. So those are all kind of cool new elements.
I thought that video for Music on Hold was really like big thinking.
Yeah, it's kind of cool. And it'll read the metadata out of the file if it's there, or it will use the name. Because a lot of a lot of people have like all their MP4s with the names in a certain format. You could parse right out of the file name. So we picked whichever one is available and show a little gray banner for a second, kind of like the beginning of an MTV video, like when it tells you who it is and the artist, and then it'll fade off again and play it. And it'll just stream through it. You can just put a directory with a whole bunch of files in there.
Yeah.
And you can almost use that as the IPTV platform if you really wanted. We use our actual conference for our ClueCon Weekly call, which is every Wednesday. That's a community call for the FreeSWITCH project, and it's basically a webcast, and it's broadcast to YouTube like directly from FreeSWITCH. So that's another cool thing to do, is record the video to something like YouTube, and then using some of our layouts and stuff, we kind of give the same effect as the news channel. When they show the people being interviewed next to each other, and then the screens kind of change around, and so you can do some of that kind of stuff too. That's kind of what video brings to the table.
Yeah. Right. Thank you.
This is a three-part question. So the video transcoding is very resource intense. How many participants can you host with one server? And is it possible to delegate the MCU part into another server and scale that one up?
Well, what we do is, it's typically the encoder that's the most expensive. Decoders are fairly optimized, and you can have a lot more of them, but encoders, they basically cost 1.5 gigahertz of CPU time per encoder that you have. So one really good solution is to pick a multi-core box, because FreeSWITCH is a heavily threaded application and makes a lot of use to lots of cores. So if you have a lot of cores and you light it up with video calls, you can actually see, or go into HTOP and see all the processors in use. But we have some features to do things like share one encoder for an entire conference. So as long as everybody has enough bandwidth to receive the exact same signal, we encode the whole thing at once and then distribute it to everybody else. And that will allow, so you're only spending one of those encoders for each different conference. And so in an extreme test to try and really prove how many we can get, I think it was 64, had 64 different video streams, you know, into a little, like super Brady Bunch mode. That's not super practical, like, because I don't know how many people could stay quiet in a conference full of 64 people, but I mean, by the same token, you could have a bunch of people in more conferences side by side, but there would be one encoder for each one of them then.
Any more questions?
Can FreeSWITCH support multiple streams coming in from within one SDP? With basically, if I wanted asterisk 15 and its SFU capability to chuck out to FreeSWITCH to get, say, the best of both worlds for two different scenarios, can I do that using FreeSWITCH as it stands today?
No, we don't have that. That one, I've never quite been sure what the final way that's going to work is. I've had that in mind before, but that's kind of one of the things I was waiting to figure out which way of doing it is going to prevail out of a bunch of competing ways, and it just didn't seem like maybe that's figured out now. Seems like it's coming.
It's technically figured out in the browser world, but no one is actually all together yet. So Asterisk has implemented Unified, the way that they use simulcast, but Browserland is actually going towards Plan B. So yeah, it's wise to wait for people to deal with it.
What sort of deployment scenarios do you most often see with FreeSWITCH in the last few years? Is video being implemented by enterprises? Have you seen anything like that?
Video has been picking up. We still have a healthy number of SIP aggregation. Very popular for carriers to move their SIP traffic, but since we started doing the video stuff, we kind of opened the gates to a new type of user that probably would have overlooked us in the past, that specifically like video features, and a lot of them do stuff with our conference module, or transcoding calls, or bridging, we get, actually, a very popular category is hearing impaired. There's several companies that utilize the video to do things like talk to an interpreter over the video call and then have a conference with a hearing person. So the deaf person can call anywhere he wants and talks to the interpreter through the video, and then the interpreter talks to whoever. So you can just call like any place without worrying about supporting special impaired stuff like TDD, TTY, or whatever. And there's a lot of different stuff in that field. There's been a huge uptick in that. And but yeah, it's pretty much spread. Most of our functionality, we have someone that uses all of it.
Is there anything beyond audio and video, for example, screen sharing or something, what you asked to mix multiple streams for augmented reality and so on?
Well, there is right now the screen sharing that we do is part of WebRTC already. So we're limited to that, which is it's basically just another video stream that they've taken. Multiple streams thing is very interesting. I think that it's kind of a conversation still going on about like all the different ways to deal with it. But I think that it's converging towards a world where it will be more, I think it's because of NAT and stuff like that, that everyone really wants to just do everything on one port, and with there's some of it is based on like a thought experiment rather than reality, and I think some more reality still has to come out and be tried to figure out the right way. But there's always a thought experiment about this guy who's at a coffee shop, and he's on the Wi-Fi there because he doesn't have much data plan. And then he's late for a meeting and he gets out and he doesn't want to hang up the phone call he's on, so he runs out and all of a sudden his LTE kicks in and it's going to magically forward over so he can stay on the phone. And I think that, like, that paradigm has driven a lot of the strategies where I'm not sure that it even works still, yet that's kind of what the goal is, to solve stuff like that with the connectivity with ICE and multiple streams. And well, we're headed to a place where we're going to have one ICE stream and then all the communication is going to be pushed over it. I think it's very similar to what FaceTime does for Apple. But at the same time, it causes some legacy and compatibility stuff where you're forcing everybody into trying to do this multiplexing thing to the point that this there should almost be a transport protocol specifically for all of the stuff over one wire rather than make everyone keep implementing it. But I think they don't care about that because everyone's using the same code base right now. But as this matures, more people might want to implement their own stack. So there's a lot of like banter going on in the development and like, let's go WebRTC. I don't think they have it all sorted yet, but that's where I see it going. So the augmented reality is a cool new idea. Going back to the question, we'd like to see that. Would be fun things to add on there.
We're out of time, so.
That's good. That was good.
Thank you so much.